All right, hello. Before we get started with today's lesson, I know we've got some homework questions to go over, so if you want to grab your homework quick, still looking really good what I'm getting back from everybody, so keep it up. But let's talk about the questions that a few of you had some issues with. A couple of you had questions with number one. What's the following is equivalent to log base 3 of 9x? So remember our log properties. 1 log multiplied, we can split that up. This is 9 times x. Everything inside is being multiplied right now. We can make that 2 logs that are added, right? So this would become log base 3 of 9 plus log base 3 of x. But that's not an answer. It's because log base 3 of 9, we can evaluate 3 to what power gives you 9? 2. So I saw in a couple papers log base 3 of 2. That's not exactly right. The whole log means this whole piece here is 2. So it's 2 plus log base 3 of x, choice 3. All right, another one that I know a lot of people had issues with was number 4. The expression log base 3 of 20 can be rewritten as, this one you almost have to just go backwards. Why don't you take all these and smush them together and see which one will actually work. So if I did number 1, there's a number out front. What can happen with that? That goes in as an exponent. So this would be log base 3 of 2 squared plus log base 3 of 5, which is log base 3 of 4 plus log base 3 of 5, if we do what 2 squared is. And now I have 2 logs added. How can I make that into 1 log? If you multiply them. So it'd be log base 3 of 4 times 5. That's why it's choice 1. 4 times 5 is 20. 2's not right, because if I put the 2 in, it's going to be as an exponent, so that'd become 10 squared, that'd be 100. This isn't right, because 2 logs added becomes 1 log multiplied. It'd be log base 3 of 15 times 5, which isn't 20. And this one, you're going to be way too big. Put this in, you're going to be log base 3 of 4 squared, so that's already going to be 16. This is going to be log base 3 of 4 cubed, 64. No way that's going to become 20. Okay. Other ones that a lot of people missed was on the back. A couple people had questions on number 9. So this is 1 log. I saw 2 ways to do this. I would have thought everything's being divided. So my way to do it was to do log of 1 minus log of x squared. And some people were confused about this. Remember, anytime you have a log of 1, log, we're going to talk more about this in class today, is really log base 10. That doesn't even really matter. Whatever the base is, what the base raised to what exponent, any base raised to what exponent is going to give you 1. Anything to the 0 is always 1. So this piece here is 0 minus log of x squared. And I can bring the 2 out front to make this just a minus 2 log of x. The other way I saw it, which I really liked, someone said, okay, well, this is the same as log of x to the negative second power. That's very smart. Exactly right. Because we can always rewrite a fraction with a negative exponent. Then I would just bring the negative 2 out front. Negative 2 log x. Done. Love it. Okay. The only other issue I saw, a couple of you on number 13, this is 2 logs added, so I can't split that up at all, because this is just a log added right now. But 2 logs added become 1 log what? Multiplied. X plus 3 times x minus 2. And then what do you think you'd do? Yeah, you'd FOIL or box it out, get your answer that way. Okay? All right, well, I know I didn't answer everyone's question, but I hope I at least answered some of yours. And if you have more questions that you still really want me to talk about, I'll try to email you about them. But let's switch over now to a warm-up. And this warm-up is more of notes than it is warm-up, because some of this stuff we haven't really talked too much about. You should be able to complete the table, so let's fill that in quick first. Log base b of x plus log base b of y. 2 logs added becomes 1 log. Log base b of, right, x times y. How about 2 log subtracted? Log base b of x minus log base b of y. 2 log subtracted becomes 1 log divided x over y. And then finally, if I have this number out front, that's going to go in as an exponent. So we're going to have log base b of x to the n power. Okay, so those are the 3 log properties we did yesterday. If I now wanted to write as a single log, I have 3 logs that are subtracted here. Let's just take it 2 at a time and make sure, again, if you need to write these down. So go to today's note sheet. It's day 4. We're going to go do that in a second. This is unit 12, day 4. Write it down off to the right over here, write it up at the top, write it on a separate sheet of paper, whatever you want to do. But this is part of the notes, and you are going to see these questions show up in the homework tonight. So definitely write these down. Anyways, 2 logs subtracted. How can I make that into 1 log? It'd be log base 3 of 1 log divided y over z minus log base 3 of w still. So now I still have 2 logs subtracted. So what can that become again? Again, 1 log divided. So log base 3 of y over z all over w. Okay, but we wouldn't really want to leave it like that because we have a complex fraction in here. So remember a couple units ago we talked about complex fractions. How did I deal with those? What did I do to them? Well, I looked at all the mini denominators. In this case, that would just be z. And I multiplied each piece by that mini denominator. So just doing some algebra cleanup in here, we'd have log base 3 of y over wz. And that's our answer. Now the shortcut, when you see a big string with all subtracted, that's a little bit annoying. Anytime there's a minus sign in front of a log, when you're combining them, it just means that those are going to be in the denominator. So y is on top, there's a minus in front of the z, there's a minus in front of the w, those are in the denominator. So if you understand that trick, you can jump right to this final step. Okay, now 3 gives people trouble a lot. If log base 10 of 3 equals a, and log base 10 of 7 equals b, express the following in terms of a's and b's. And there's your random fact. Cold water weighs less than hot water. Try it out. Okay, anyways. We did questions kind of like this yesterday. I want to substitute in for a and b, but I can't do that substitution until I have log base 10 of 3, log base 10 of 7. So when I see 21, I want to first think, how can I write 21 with 3's and 7's? And obviously, it's 3 times 7. And again, I chose 3 and 7 to use only because my directions have everything in terms of log base 10 of 3 and log base 10 of 7. So before I can start subbing in, my answer is not a times b because I have to split those up. I have to have just log base 3 of 10, or 10 of 3, and just log base 10 of 7. So 1 log multiplied becomes 2 logs added. Log base 10 of 3 plus log base 10 of 7. And now I can sub in. Log base 10 of 3 is a plus log base 10 of 7 is b. So it's a plus b. Kind of tricky. All right, how can I write log base 10 of 49 using only 3's and 7's? In this case, I just need 7's. And I could write it a couple different ways. We could say log base 10 of 7 times 7, or couldn't I also just say log base 10 of 7 squared? Sure, I could. And how could I use log properties if I start like that? I can bring the 2 out front. So 2 log base 10 of 7. Writing it in terms of a and b, we know what b is. What's my answer? Right, 2b. Okay, and lastly, 90. Again, I only want 3's and 7's. So when I see 90, I first think, okay, I can definitely put a 3 in. It's 3 times 30. and then, so that's fine. 30 then is 3 times 10. There's no way I can get any more 3's and 7's out of that. So I have to leave the 10, but let's see what happens. 90 is log base 10 of, I could write 3 times 3 times 10, or I could write 3 squared times 10. So then if you split that up, it's going to be log base 10 of 3 squared plus log base 10 of 10. I can still bring this 2 out front to make it 2 log base 10 of 3 plus log base 10 of 10. What's this first piece going to turn into using my directions? 2a. Well, what's log base 10 of 10? 10 to what power gives you 10? 1. So it's 2a plus 1. So that's why the log of 10 didn't really matter, because it matched my base and I could evaluate it. All right, so again, I know that's a little tricky. You will see a couple homework questions like that. So if you haven't written those down, you should pause the video and do that, because you might have trouble if you don't have something to reference. All right, so then for today's notes, let's go over to this. Base day and domains of logs. Have your calculator out too. So today's a big calculator day. If you don't have your calculator out, pause the video and grab it. And let's get started. Okay, so we haven't talked about really how to do anything on the calculator yet this unit, and that's what the first part of today's lesson is going to be. We talked a little bit yesterday about what the common log is. The common log is log base 10. So if I write this, normally you're just going to see me write this as log of 10. Writing the base of 10 looks pretty weird to math people. So you're not normally going to see that base 10, it's just going to say log. The other one that you can do on your calculator is the natural log, log base e. And rather than writing log base e, they write ln of x. And you can see both of those are on your calculator. There's the log key, that means log base 10. We just did log base 10 of 10 in the warm-up a second ago. We said that was equal to 1. If I do log of 10, I get 1. ln is right below it, and they kind of look at the calculator as almost a cheat sheet. It tells you base 10 right above it, base e right above it. So that kind of is a way to show you. So if I wanted to evaluate log base 10 of 6, if it's log base 10, I can do it on the calculator. I can just go here and I can say log. You don't need to write base 10 because it means that. So I just write log of 6 and I get 0.7782. So we would just type log of 6. It's about equal to 0.7782. And it should make sense that it's an irrational number. It's not a nice exponent. 10 raised to what power gives you 6? Not a nice one. We know 10 to the 0 is 1. We know 10 to the first is 10, so 6 should be somewhere between 0 and 1, which it is. If I see log base e of 1/2, how would I do that on the calculator? I would just type ln of 1/2. And I get negative 0.6931. I'm going to see log base e. I'm going to do ln in the calculator. And we got about equal to negative 0.6931. Okay, but then what if I get something like log base 3 of 7? Well, I don't have a log base 3 key on here. I just have 10 and ln, so it's not base 10 or e. Oops. Not base 10 or e. So we can use an old strategy that I did a few days ago. Let's set log base 3 of 7 equal to x. And then what can I do to both sides? I could exponentiate by 3. So I'd have 7 equals 3 to the x. And then if I wanted to solve for x, because I can't get common bases, if I want to get rid of this 3, what can I do to both sides? I could take log base 3. So log base 3 of 7 equals log base 3 of 3 to the x. That's what we've done before in this situation. This cancels. I kind of get right back to where I started. X equals log base 3 of 7. So that didn't really help me. Here's another option. If I had 7 equals 3 to the x, let's say I just took the log of both sides instead. Log of 7 equals log of 3 to the x. How's that different than what I did over here? Is this log and 3 going to cancel? No, because the bases are the same. What aren't the same? What's the base on log? Log base 10. So log base 10 and base 3 don't cancel out. So I don't have this situation, but instead, what could I do with that x? Well, think of your properties from yesterday. It's an exponent, so where can it go? Right, in front. So I'd have log of 7 equals x log of 3. If I want to solve for x, this is just x times log 3, so I could divide. And I get x equals log of 7 divided by log of 3. Now the advantage to that is we can use the calculator now. I can type log of 7 divided by log of 3 because that's log base 10. And I do get an answer, 1.7712. So that is what log base 3 of 7 is. Think about it, it should make sense. 3 to the first is 3, so it's going to be bigger than 1. 3 squared is 9, so it's going to be less than 2. 7's closer to 9 than it is to 3, so it's going to be closer to 2 than it is to 1. Yeah, that makes sense. Okay, but look at what we just did. We developed something called a base change formula. I solved this equation 2 completely different ways, and in both cases I was able to solve for x. The algebra I did was totally legitimate, so if those are the same x's, then the only thing that can be true is that log base 3 of 7 is equal to log of 7 over log of 3. So in general, if you have log base b of x, you can say that's equal to log of x divided by log of b. The advantage there is we can plug that into the calculator. Notice so log base 3 of 7, the thing inside the log is the top one, the base is the bottom. I just keep remembering base bottom. Okay, so now let's do that. Evaluate each defining logs to the nearest hundredth. Try it on your calculator. Log of 7. That one's easy. I can just type log of 7. Done. 0.845. We said nearest hundredth. Watch it rounding. 0.85. ln of 3. Soup ease. ln of 3. Answer 1.098, so 1.10. Okay, when I get down to C, log base 4 of 6, I don't have a log base 4. All I can do is this base change thing. So remembering base bottom, we're going to write this as log of 6 over log of 4. And then I can type it into the calculator, log of 6 divided by log of 4, 1.29. Okay, I'd like you to pause the video for a second. Do the same with D and E. They're not log base 10 or log base E, so you're going to have to use that base change formula. So rewrite it with the base change formula first, then plug it into your calculator and see what you get. Let's go ahead, pause it, and give that a try. All right, assuming you've tried it, here is what you should have gotten. For D, you should have written log of 3 over log of 5, base bottom. And when you typed it in, log of 3, make sure you close the parentheses, divided by log of 5, should have gotten 0.68. Now this one you might not even need a calculator for. Log base 7 of 7 is log of 7 divided by log of 7. So already, what should it equal? Anything divided by itself is always 1. Your calculator can do it. Log of 7 divided by log of 7 will give you 1. So that one you could have done in your head, but this gives you an option. If you have problems evaluating logs, you can always use your calculator to evaluate them that way. Questions? All right, now I can't really show you this, but there actually is even a newer way that most of you can evaluate logs without even worrying about this change of base thing. The only calculator I have on my computer for this video is a pretty old calculator, and some of you might have these still. But go to your calculator right now and click the math button and scroll all the way down. My calculator is not going to have it, but the newer calculators, you should get down to an option A. Mine just goes back to 1. But if you scroll down to option A, after 0, it should say log base. So if you have a new calculator, go down there, do that log base, and then you're going to get something like this that pops up. It'll say log with a little box and a little box like that. And that's really nice because then you can plug whatever base you want here. Like try D. If you put in log base 5 of 3 and close the parentheses and hit enter, you should get that number right away. So for those of you with those newer calculators, if you have that log base key, use that to your advantage. It's way easier. But if you don't have a new calculator, this is how you would do it, using that change of base formula. Okay? All right, let's go over to the back. A couple more things we're talking about today. Solve graphically to the nearest hundredth. So I know you could solve this algebraically. If you wanted to solve it algebraically, what could you do? You could exponentiate by 2. You'd get 2 to the 4/3. But there is one on the homework tonight that you can't solve algebraically. So if I want to do a log equation graphically, how do I always do stuff graphically? By doing y1, y2. The only thing is, if you have a new calculator in y1, you can use that log base key and do log base 2 of x. If you have an old calculator like I have, I'm going to have to write this as log of x divided by log of 2. So go ahead, however you want to do that, go to y equals. Newer calculator, I'd use that log base key in the math menu. For me, I'm going to have to write log of x, close the parenthesis, divided by log of 2. And y2, I'm going to put 4/3. And then if we're solving something graphically, where do I always have you go next? Zoom standard. So there's my graph. There's the line coming across. I don't have to adjust the window. You may have to if it doesn't show up nice. But I do, as always, need to see a graph. So it looks something like that. And then I got to find the intersection if I want my answer. So I'm going to go second calc, intersect. Now if you just try to hit enter right now, it's not on the curve yet. So arrow over to the right a little bit until you start seeing the cursor, then hit enter. Hit enter again. Go over to where you think your answer is, enter. And I get, it's always the x value that I'm trying to solve for. So to the nearest hundredth, it'd be 2.52. Okay, so in the directions on your homework, when you see the graphically one, that's how I want you to do it. All right, now the last thing we got to talk about is domain of logs. And before we get into the domain of logs, let's talk about domains that we know so far. It's been a while since we've done these, but when we're talking domains, we think, what am I allowed to plug in? So we did them with rational functions. What was the restriction with rational functions? What am I not allowed to do in a fraction? The restriction here is that the denominator, x minus 3, can't be 0. And that's how we did domains for rational functions. We set the denominator equal to 0. In this case, can't be 0. So x can't be 3. Remember, that means it's not 3, but it is anything else. So the domain would have been negative infinity to 3, union 3 to infinity. That's an interval notation. Remember, in set notation, we would have said x such that x cannot be 3. Okay. What's our restriction with radicals? What are we allowed to put under radicals? We can put positive numbers, or I can put 0. So for radicals, the restriction was always whatever's underneath the radical has to be greater than or equal to 0, because I can have radical 0. So here I would have x is greater than or equal to negative 2, which means here's negative 2. It can be that because it's greater than or equal to, or anything bigger. So my domain, I'd either say bracket negative 2 to infinity if I was doing interval notation, or in set notation, I would say x such that this, x is greater than or equal to negative 2. You only have to say one of the answers, but sometimes I specify one. Okay, so those are mainly the restrictions we've seen so far this year. Fractions, denominator can't be 0. Radical, underneath the radical, has to be greater than or equal to 0. What about logs? Well, let's think about in terms of inverses. We did a lot with y equals b to the x in the last unit. What was the y-intercept always for an exponential? 0, 1. And what was the asymptote always? Y equals 0. And assuming base was bigger than 1, it would look something like that. So we said the domain of all exponentials was negative infinity to infinity. That was an easy point on your test last week. The range was 0 to infinity, like that. Because I can't include 0 because of that asymptote down there. Now what was the inverse of y equals b to the x? If you wanted to switch x and y and get rid of that b, you take the log base b. That's been the whole purpose of this unit. The log base b of x is the inverse of b to the x. So if I was graphing that, think about it in terms of this graph. Instead of 0, 1, what point would I have over here? 1, 0. And instead of y equals 0 being an asymptote, I'd have x equals 0 being an asymptote. And your graph would look something like this. The domain over here, I can't go left of 0, and I can't even get to 0 because of that asymptote. So it'd be 0 to infinity. The range goes down forever for sure, and this is growing forever as well. So it's negative infinity to infinity. And that should be no big craziness because domain and range always flip when I have an inverse. The important thing here is the domain. The domain of a log is 0 to infinity, but not including 0. I can't put 0 inside a log, and that should make sense. Because if I have a base raised to what power is going to give you 0? Nothing. So here's the rule. If you have y equals log base whatever of something, I'm just going to call it star, the stuff inside that log, star, has to be strictly greater than 0. So a little bit different than radicals, which could be 0. Logs can't be 0, but can only be positives. So from this, we're going to see that logs can't be 0 or negative. And we're going to come back to that idea in a couple days. maybe even tomorrow. All right, so the new piece today, when I'm asking you to find the domain of a log, we're going to set stuff inside log greater than 0. All right, so 2 quick examples and then we're done. Find the domain of the following functions in interval notation. So I see that it's a log. So since it's a log, I would say the stuff inside is greater than 0. Make sure you understand why that's different than radicals. Radical 0 does exist. That's why up here, I'd set the stuff under the radical greater than or equal to 0. But I just showed you that because of that asymptote, logs can't be 0. So the stuff inside is just greater than 0. So x is greater than -2. In interval notation, that would be parenthesis -2 to infinity. So again, compare it to that answer with the radical. Almost the same, except parenthesis here instead of a bracket, because the stuff inside a radical can be greater than or equal to 0. The stuff inside a log can just be greater than 0. Doesn't matter the base. Log base 3 of this stuff, same idea. Since it's a log, the stuff inside it, if I'm finding the domain, has to be strictly greater than 0. -5x is greater than -3. What happens when I divide by a negative? That sign flips. X is less than 3/5. So think about what that means in interval notation. If I'm less than 3/5, I can be all the way over to -infinity up to 3/5, but not including it because logs can't be 0. Okay, that's it. So give tonight's homework a shot. And I think on the homework, there might even be some other logs mixed or some other domains mixed in. So remember those other restrictions as well. Good luck. Email me with questions.